So number 30 was a bonus question based on the previous roadmap that was number 27, 28, and 29. And they tell you, here was your structure Z. And they said, okay, so we're going to take structure Z and make this. Yeah, this. And they said you can either give the name of the reaction that makes this, or give the reactants that make this over the arrow. So let's start by trying to identify where are the pieces that we have in common. And so we look at our structure Z and we see two things. We see a 6-member ring and we see a 5-member ring. So now I'm going to go here and I'm going to look for those 6 and 5-membered rings. Well, I think one that stands out pretty well is the 5-membered ring because it has an oxygen in it. And that must be this oxygen right here. And hey, look, it's part of a 5-membered ring right there. So let's go about numbering this 1, 2, 3, 4, 5. Okay? So the carbonyl was 1, 2, or I need to number it this way. 2 was the carbonyl, 3, 4, and 5. And notice 3 and 4 were on part of the 6-member ring. And look at this, 3, 4, and then I have a 1, 2, 3, 4, 5, 6-member ring right there. So they drew it in the chair conformation, but it's still a 6-member ring. So let's say 3 is connected to 6, 7, 8, and 9. So 3 was connected to 6, which had a carbonyl. 6 was connected to 7, and 7 had a methyl, so there it is. 7 was connected to 8, and then 9 was connected to 4. So these carbons, these 9 carbons, must be the carbons from Z. So now we know which carbons we need to add. We need to add 1 carbon here, 1 carbon here, a nitrogen, a carbonyl, and then not a carbonyl, a carbon, and then another carbon that's part of the benzene. So those are the things we need to add. Now, how do we add them? Now, this is the trick of the question. To recognize what you have made here, we have to point out a pattern. And that is the pattern that you, how to say this? The pattern is the positions of a carbonyl relative to what else is on it. Now that wording is kind of poor, but what I mean is if I look at carbon 6, 7, and this carbon over here, well, carbon 6, I'm going to renumber that. Now that I've identified which carbons are which, let's say this is carbon 1 for a second. And then I have 2, I have 3, and then 4 is a nitrogen. Now, one thing that you'll see is a certain reaction from exam 3 puts a nitrogen on a carbon 3, or so if I was numbering it this way, puts a nitrogen relative to a carbonyl in this position. Namely, it's the Mannich reaction. If you take carbonyl, let's say a ketone like this, and you react that with a base, so, or not a base, you treat that with an H+, a formaldehyde, so a CH2 carbonyl, and then whatever amine group you want to add. So let's say it's NH2 or NH3 in this example. What you end up doing is you take 1 carbon of the ketone, connect it to the carbon of the formaldehyde. So this carbon right here gets connected to the carbon of the formaldehyde, but rather than it being a double bond O, you end up having a nitrogen attached. And that nitrogen will be whatever nitrogen and carbons are on that nitrogen over the arrow. So in this case, it would be NH3, but that would make the nitrogen positive, so we're just going to remove a proton through the mechanism that I'm not drawing out. And that would be NH2. And now notice, the product of any Mannich reaction involves a carbonyl on 1, a carbon 2, a carbon 3, and on carbon 3 is nitrogen number 4, which is what we have here, 1, 2, 3, 4. But we also have it here, 1, 2, 3, 4. So this reaction is actually the product of two, or this product is the result of 2 Mannich reactions. Now how does that work? Well, we already see which carbons we needed to add. We need to add this carbon right here, and that's it, because carbon 2 is right there. So the carbon that's connecting is, I didn't number this the same way because I erased the thing. Let's put these numbers back. So this was 3 was connected to 6, and 6 was connected to 7. So the carbon that I need to react with is carbon 7 first. Let's do carbon 7 first. So carbon 7 is going to react with the Mannich reaction. So I need a formaldehyde. Formaldehyde will always be the same for the Mannich reaction. So I have C double bond O, CH2, or CH2 double bond O. I have H plus. Now what is the amine group I need to add? The amine group I need to add is a nitrogen with a benzene, with a nitrogen with a carbon and a benzene attached. So I'll also have nitrogen, 1 carbon, benzene, and now I just need to have the appropriate number of hydrogens on that nitrogen such that it is neutral. So that means it needs 2, NH2. And now if I do the Mannich reaction, carbon 7 will now become connected to this carbon of the formaldehyde. Excuse me. Let's draw everything the same as we have it. So carbon 7 has a methyl, but now carbon 7 is also connected to the carbon of the formaldehyde. That carbon of the formaldehyde gets connected to the nitrogen. That nitrogen has 1 carbon and then a benzene, 1 carbon and then a benzene. And then it just needs the appropriate number of hydrogens to be neutral. So this would be the result after 1 Mannich, but we seem to be wanting to make a 6-member ring. So there's going to have to be a second Mannich. But in this case, the nitrogen is already in the ring, so all you need to do is add a second round of formaldehyde and H plus. So now where does that second carbon have to get added? Well, we justified how this carbon over here was added, but we haven't said how this carbon was added. And this carbon was attached to this carbon over here, carbon 3. The carbon that was alpha to these 2 carbonyls. So in this case, what happens is that methyl, so what happens is you get 1 carbon added to the alpha position. So you have 1, 2, here's 3, and now that 3 will end up getting connected to the nitrogen. Now I'm drawing this ugly, but if you think about it, so we have nitrogen, so this is 1, 2, 3, 4, 5, 6, and while I drew this as a rounded bond, this is only 1 bond, and so it makes a 6-member ring if I do this second Michael addition, which if you look here is a 1, 2, 3, 4, 5, 6-membered ring. And so this question was meant to be a bonus, which is why it's so ugly looking and why they made it look so ugly looking in the first place, because it doesn't penalize you for getting it wrong, but it gives you a free 5 points if you get it right. So what needed to be over the arrow? What needed to be over the arrow was step 1, CH2 double bond O, H plus, and NH2 with a benzene and a carbon. And then step 2, another round of CH2 double bond O and H plus. That would have been 5 points, or you would have said the Mannich reaction. You needed to either identify the reaction or give the reactants over the arrow. But this question was kind of crazy, so it's okay if you don't get it right or if you don't understand it fully, because this will never be a question that is straight up worth points that you would lose if you got it wrong. It's just that complex.